robust and compact reactor. Arc reactor is first introduced in the Iron Man 1 movie in 2008, where due to a bomb blast, metal pieces of grenade penetrates into the chest of Iron Man, and to prevent them from being reaching to the heart of Iron Man, Tony Stark, the scientist inside the cave inserted an electromagnet inside the chest of Iron Man, and which is powered. The electromagnet was powered by a battery of a car, and that to replace the car battery, Tony Stark made a arc reactor. Arc reactor contains the electromagnet and a power source in itself. So let's talk about how arc reactor work and is it possible in real life. Hello and welcome to Earthian. Arc reactor basically works on fusion technology. Fusion technology is the technology on which the sun keeps burning, or you can say sun makes energy. In this technology, to understand fusion, let's understand nuclear reactions first. There are two types of nuclear reaction. There are two types of nuclear reaction. The first one is nuclear fission and the second one is nuclear fusion. In nuclear fusion, a radioactive elements, we take nuclei of an atom of a radioactive element and break it into two parts. So by breaking it into two parts, some energy is released. According to Einstein, C equals to mc square, mass energy relation. Some mass is lost and which is released in the form of energy. So we harness this energy. Basically, it is released in the form of heat to make electricity or any other form of energy. It is necessary that nuclear fission is conducted only by radioactive element. Nuclear fission can be of two types. It can be controlled or even uncontrolled. To control it, we need cadmium rod by which we control the reaction. The reaction happens in a form of chain. In uncontrolled reaction, there is nothing like cadmium rod. We can see an example of uncontrolled reaction in atom bombs, where uncontrolled reaction happens and it is very disastrous. Now let's talk about nuclear fusion. In nuclear fusion, it is not necessary to take radioactive element. Mostly we prefer to take heavy isotopes of hydrogen atom, especially tritium and deuterium, and we use these proton of tritium and deuterium and fuse them together. To fuse them, we need a large amount of energy, basically speed, because the proton of an atom is positively charged and another proton of an atom is positively. So to combine two protons, when we combine two protons, they repel each other. So to fuse them, we need an enormous heat, or say kinetic energy, and this can easily be happened in sun due to its heavy mass and heat. But on earth we need large amount of energy. So we haven't harnessed fusion for electricity or other energy, but we have made the hydrogen bomb using fusion technology. In fusion technology, in hydrogen bomb, we do nuclear fission first, by which we get sufficient heat energy to start fusion reaction, and thus before fission and after fusion, a large amount of energy is released, and that's why nuclear fusion is more powerful and gives more energy than nuclear fission. In this also, loss of mass takes place, and which is converted into the form of energy, and we harness this energy to use it for various purposes. Okay, scientists have developed two ways of harnessing nuclear energy, but none of them was so much efficient. In them, how much energy we apply, we didn't get back that amount of energy even. So we will discuss two ways in another video. Thank you. Is arc reactor possible in real life? So the basic and simple answer is no, because arc reactor produce so much energy, approximately 3.3 gigajoules of energy. Store such energy or create such a large quantity of energy at a small place like a thumb size container. So that energy is going to blast, and it will blast the whole city, will destroy the whole city, not only the man who is wearing that. And it produces such a large quantity of heat that it is basically impossible. You already know the arc reactor or nuclear reactor, which produce less energy than fusion, and even though it requires such a huge protection uh, infrastructure to protect radioactivity from escaping